All right, we have a bunch of things to worry about here. We have x-intercepts, we have y-intercepts. That's typically what I take to start out with. Your x-intercept, your y-intercept. Your x-intercepts is where your function, your y is equal to 0. Where your y is equal to 0. Okay, when we're talking about a rational expression, what makes a rational expression equal to 0? Is when your numerator is equal to 0. When your numerator is equal to 0, that will tell us our function is equal to 0. So if we take a look at our x-intercepts, that's where y is equal to 0. We're taking a look at what makes our numerator equal to 0. So we factor it. If we would factor our numerator, what is it factored to now?
X minus 5, x plus 1.
X minus 5, x plus 1. So our x-intercepts will occur where?
-1 and 5.
So we have x equals -1 and 5. Our y-intercept is where x is equal to 0. So wherever I see an x, I'm putting in a 0. So we have 0 plus 0 minus 5. So we have -5 over 0 minus -1, which is -1. So we have a y-intercept at a value of 5. Our discontinuities. Our discontinuities is where our denominator is equal to 0. What makes our denominator equal to 0? So we're looking at x squared minus 1 equal to 0. One, and also x equals 1 and -1. And once again, we can factor this x plus 1, x minus 1. Okay, so now we take a look at our discontinuities. We need to determine what occurs at our discontinuities. We have two things that could occur at our discontinuities. We have an open dot, we have vertical asymptotes. So let's take our limit, and the only way we can determine this is taking our limit as we approach each one of our discontinuities. Now, what I would suggest you do, because you've already factored down to find your x-intercepts and your discontinuities. So write it in a factored form. So we have the limit as x approaches 1 of x minus 5, x plus 1, x plus 1, x minus 1. The x plus 1s, they go away. So we factor, we cancel, and we try to sub. And we're left with -4 over 0. So were we able to remove the discontinuity? No. So if we can't remove the discontinuity, your discontinuity is not removable. So what's going to occur there is you're going to get a vertical asymptote at that discontinuity. And we go through the exact same process as we approach -1. So we write it in factored form, but we have the limit as x approaches -1 now. We factor, we cancel, and then we substitute our -1 in. So if we substitute -1 and we get -6 on top, -1 minus 5 and -1 minus 1. So we get -6 over -2. We get a value of 3. So we're able to remove the discontinuity. If we're able to remove the discontinuity, what do we get there? If we can remove the discontinuity.
Open dot.
We have an open dot. So we have an open dot at my discontinuity, -1, and our limit as we approach that discontinuity. Horizontal asymptote. We take the limit as we approach infinity of our function. Now, I would not look at my factored form of that. I would go back up to my original form. And to save myself a step, to find an infinite limit, I'm going to divide through by what up here?
X squared.
X squared. So mentally, I'm going to divide through by x squared. Top and bottom. So we're left with 1 plus 4 over x minus 5 over x squared. On the bottom, we're left with 1 minus 1 over x squared. These all go to 0, so we're left with 1 plus 0 minus 0. And then 1 minus 0 on the bottom. So we get a value of 1. So we have a horizontal asymptote at y equals 1. So getting our graph down, we have a horizontal asymptote at y equals 1. We have a vertical asymptote at x equals 1. We have an open dot at x equals -1, y equals 3. We have a y-intercept at 5. We have x-intercepts at -1 and 5. Are those correct x-intercepts? Should this be a +5 and a -1?
Yeah.
So this should be a +1 and a -5.
It's not -1 and 5.
This factors x plus 5 and x minus 1, correct?
Oh no, the 4x is negative.
So the 4x is negative?
Yeah.
Oh, alright. So this would be negative, so we were correct then.
+1.
So it's a negative 4x, so this is minus 5 and plus 1. So that can be negative 1 and positive 5. Something's wrong here. Oh. Is that the correct? So all my signs are bad here. Or discount, everything's wrong because of that. Because this should be, okay, minus 5 plus 1, plus 1 minus 1. Okay, I guess we're good.
I think it's still the same.
Yeah, it's still the same because I had to correct. I did what you did here, minus 5 plus 1. My x-intercepts are off though. Okay, I see where since I have a removable discontinuity, oh, that's where since this discontinuity is not removed or is removed, this here is a removable discontinuity. Since it is a removable discontinuity, we will not get any x-intercept at that value -1. Reason why is think about if I was going to list a domain for this function, I want to graph this function. My domain of this function is set of values x to the member of real x cannot equal 1 or -1. But to say my x-intercept is at a value -1 would be incorrect. That would be incorrect because I had to eliminate it from my domain. So my x-intercept at the value -1 is not going to work. But I have have an x-intercept at a value of 5, that will still work. So if I take a look at my graph, what's going to occur in my graph? As x gets bigger and bigger and bigger, I'm going to approach this horizontal asymptote. I will go through my open dot, I will go through my x-intercept also, but as I approach the value of negative, or a value of 1, I'm going to approach this vertical asymptote. And we'll get this open dot here at the value of 1, -3, or 1, -1, 3. If I take a look at the bottom, I have to go through this x-intercept here, and I have to flatten out along this horizontal asymptote. As I approach this asymptote, I will go towards negative infinity. What else we can do? We can look at the limit as x approaches this value of 1 from the right of our function, and the limit as x approaches 1 from the left. If we take the limit as x approaches infinity from the right, these x plus 1s would cancel out still. These are values of x that are greater than the value of 1. On top, if I'm approaching 1, I got 1.01, 1.001, 1.0001. I'm going to get a negative value on top. As I approach on the right and look at x minus 1, I'm going to get a positive value on the bottom. But what this will tell us, tells us that we're going to approach negative infinity, which is what we are doing. As we approach from the right, we're going to go towards negative infinity. These will cancel out still. As I approach from the left, the value of 1. I'm still going to get negative on top, but now these are values that are smaller than the value of 1, 0.9, 0.99, 0.9999, and so on. This will give me a negative on the bottom because I'm subtracting it off 1. So I have negative divided by negative, which tells us a positive infinity. So as I approach 1 from the right, I go towards positive infinity. That's what my graph is doing. As I approach 1 from the right, I'm going towards negative infinity. And this is what my graph is doing. So you can take a look at limits and use your directional limits to be able to determine if you're going towards positive or negative infinities. Okay, what I want you to do is the rest of the worksheet. Okay, the rest of the worksheet, front and back. You know, you have 3 other problems to graph there. Work on them for tomorrow. All right, questions? All right, the rest of the time is yours.